Hello student, in this video we will study about the chapter light. So this video is specifically for CBSE 10th grade student. So light chapter is divided into part 1 and part 2. In first part we will cover reflection of light module. Hello student, Anand Academy providing CBSE and ICSE board classes from 6th to 12th grade, and we are taking maths, physics and chemistry classes. Mode is both online and offline. Our center is now in Bangalore, so if you want to know more, you can visit anand.academy or you can call on this number. So before we start reflection of light, we first see the introduction of this chapter. So in introduction, first we will know the definition of light. Light is a form of energy through which we can see the object. Any object around us we can see through the eye. But at night, when there is no source of light is present, then we can't see the object. Like example, if you read the book, you need a proper light to read the book. But at night, you can't read it because you will not able to see anything. So that's why light is a form of energy through which we can see the object. So how we can define the object? Anything which radiates the light, like sun, tube light. So these all are considered as object. Object is subdivided into two parts. First is luminous object and non-luminous object. Luminous object means those objects which creates its own light, like sun, tube light, bulb. So these all are luminous object, the light emitted by the object itself. Non-luminous, opposite of the luminous, means it takes the light from the others, or you can say that it takes the light from the luminous body, like moon. Moon takes the light from the sun. So at night we can see moon clearly, but moon is not producing or emitting its own light. So those objects are called as non-luminous object. The light emitted by another source and then reflected from the object, book, table, chair. So let's understand non-luminous object with a simple example. In this figure, here is a non-luminous object, and this is the sun or any luminous object. So when the luminous object releases the rays like this, when it comes to the surface, it gets reflected, and the reflected ray is followed by our eye. So if we have to see this object like chair or book, anything you can consider, so there must be the light source present. Then only we can see the object. At night, when there is no light source present, we can't see the non-luminous object. Now we will start our first topic, reflection of light. In reflection of light, we will see about the surface. Surface is when the incident ray coming out from the object and after that it gets reflected. So surface is required for reflection. If no surface is present, it means that the ray will follow the straight path. So there are three types of surface: transparent, translucent and opaque. Transparent means where the light can easily pass through it, like the glass. Through glass, light can easily pass through it. Translucent, a small amount of light can pass through it. And the opaque, no light can pass through it, like wood. From wood, light will not able to pass through it. In this figure, here is the object. It could be luminous or non-luminous. So object releases the ray. So when the ray is coming out from the object, it is called as incident ray, and we represent it as a small I. So light always passes through the straight path. So same way this incident ray passes through the straight path. And you see this is the surface. Here is the surface. So when this incident ray touches the surface, this is called as point of incidence. When the incident ray touches the surface is called as point of incidence. So in this surface, upward is the reflecting surface and the downward, which is represented as a dash. So this is a non-reflecting surface. Non-reflecting surface means where the reflection will not take place. For reflection, we need a reflecting surface. So when the incident ray touches the point of contact, after that it gets reflected. So now incident ray will become reflected ray. Next is normal. When we make a perpendicular line through the surface, it is considered as a normal ray. It is imaginary ray. Means it is not coming out from the source. So the angle formed between the normal and the incident ray is called as angle of incidence. This is angle of incidence. Similarly, the angle formed between reflected ray and the normal is called as angle of reflection. Now we will define each and every term what we discussed. Incident ray, a ray which comes out from the source. Reflected ray, when the incident ray touches the surface, it gets reflected. Normal ray, an imaginary ray which is always perpendicular to the surface. It is always perpendicular. If our surface is this is our surface, then here is the normal. But when we change the surface, so normal will be also change, but it will be always perpendicular, 90 degree. Point of incidence, a point where both incident ray and the normal meets on the surface. Angle of incidence, it is the angle between incident ray and the normal. It is represented as angle I. Angle of reflection, it is the angle between reflected ray and the normal. It is represented as angle R. Now we will study about the reflection of light. So reflection of light is a phenomenon in which incident ray touches the surface and bounces back and changes the direction. As you see in the previous diagram, so reflection of light we can easily understand by this figure. Here you see this is the incident ray. It touches the surface and gets reflected. So this phenomenon is called as reflection of light when the incident ray touches the surface and then it bounces back and changes the direction. So here reflected ray direction is changing. So then it is called as reflection of light. Now we will study about the law of reflection. So in reflection there are two laws. First is angle of incidence is equal to the angle of reflection. So we know that angle of incidence is represented as angle I and angle of reflection is represented as angle R. In this example, this is our angle I and here is the angle R. So according to law of reflection, angle I must be equal to the angle R. So suppose angle I is equal to 30 degree. So angle R will be also the 30 degree, both having the same degree. So this is the first law of reflection. Now we'll see the second law of reflection. Second law of reflection says that the incident ray, reflected ray and the normal all lies on the same plane. So first we know what is the meaning of plane. So as you see in this figure, we have x-axis and y-axis. So x-axis and y-axis forms one of a plane. So if we have a incident ray, let's assume this is the surface here. Here is the incident ray. This is normal and then it will be reflected. So you see incident ray is present in the xy plane. Normal is also present in the xy plane and the reflected ray also present in the xy plane. Incident ray, reflected ray and the normal all lies on the same plane. Suppose if any one of it is going to the z-axis plane, so then they are not considered in the same plane. But here all lies on the same plane. This question generally comes for 1 marks. So when the incident ray coincide with the normal, it means that angle I is equal to 0, then the reflected ray will bounce back and follow the same path. Why it happened? Because of first law of reflection. We know that angle I is equal to angle R. So when the incident ray is coinciding with the normal, it means that that time angle I is equal to 0 because both follow the same path and same line. So if angle I is equal to 0, so angle R must be equal to 0. So here you will see that reflected ray will also follow the same path, but it is bouncing back because it will touch the surface and then it will move the direction in opposite side, because it will touch the surface and then its direction will change, but path will remain the same. Now we'll study plane mirror. So in plane mirror, first we will note down the definition of plane mirror. So plane mirror whose reflecting surface is plane. In plane mirror, one surface is reflecting, another surface is non-reflecting, and we put a coating of silver on the non-reflecting surface. If you take a glass and over it if you put a coating of silver, it becomes a plane mirror. So how this reflection takes place in the plane mirror, we will take two examples. First, when the source is point means very small. So here in this figure, here is a object which behave as a point source. So from this source, infinite rays are coming out, but we only focus about the two rays. So if the incident ray is perpendicular to the surface we just studied, its reflected ray will bounce back and follow the same path. So this is one of our ray. Second, we took with certain angle. Here is the normal, this is the normal, and then reflection takes place. Because our eye is following the reflected ray, so if we stretch it, and this is also a reflected ray, if we stretch it, it will meet at a point P dash. So at P dash, image is formed. Next example is extended source. In extended source, we took the object which has certain height HO or Y, and then again we will do the same way as we did in the previous example. We will take two rays. One we can consider perpendicular to the surface, so it will follow the reflected ray in the opposite direction but same path. So its reflected ray will follow behind the mirror in this direction. Similarly, this is again our incident ray and here is the reflected ray. If reflected ray is stretched, both will meet at a certain point and there the formation of the image will be there. This is the image Y dash. So in plane mirror, the size of object is equal to the size of image, and also in the plane mirror the distance of the object from the plane mirror is equal to the distance of the image from the plane mirror. It means that u is equal to v. So these all are considered under the characteristic of plane mirror. So previously we studied about the object. Now we will study about the image. Image, it is a point where at least two light rays actually meet or appear to meet. So based on this, images are divided into two parts. First is the real image and second is the virtual image. How we can define real image? Real image is formed when light ray actually meet. I told you in the previous example, in this figure, you see that this is our reflected ray and here is the reflected ray. Both the reflected ray directions are different. But if we have to form the image, we need to actually meet the reflected ray or it appears to be meet or it appears to meet. By dotted line, we represent its appear to meet. Actually, the image, actually reflected ray can't go inside the mirror. So, we are assuming that it will about to meet or it will appear to meet in this direction. So here the image which is formed is a virtual image. So when real image is formed, you can take an example of a candle. Here is a candle and we place a screen. This is the screen. So we will see on the screen that the image of the candle is formed. So this is the example of real image. If you go to the movie theater where we are using a projector and there is a big screen and movie we can see on the screen. So this is also example of real image. So here we can define real image and virtual image. Real image is formed when light ray actually meet. Virtual image is formed when light ray appear to meet, as example of plane mirror. Real image can be formed on the screen like a candle. Candle image is formed on the screen, but virtual image can't form on the screen. Like you see the example of plane mirror where the image is not formed on the plane mirror, it is forming behind the plane mirror. Real image is inverted and virtual image is erect. I will explain you inverted and the erect with a example. But before that, just note down the example of real image like movie theater, candle on the screen, image formed by a concave mirror. In a spherical mirror topic, we will cover concave mirror. For virtual image formed by a plane mirror, we just saw the example, or convex mirror. Convex mirror, I will explain you in the spherical mirror topic. So let's move to the inverted and erect concept. In virtual and erect, here is a diagram. This is a plane mirror. And on the left side, we have the object. So when we place the object, the top is considered as the head and the bottom is considered as the tail. So when its image is formed, means both the head, object and the image are on the top. Same thing, tail. Tail is on the bottom. So in the virtual, when the head and head both are up, so it is erect. So here head and head both are up, so it is erect. So here it is a very simple way to remember. Up side of the object is equal to the upside of the image and the downside of the object is downside of the image. So it is called as erect. So whenever we have a virtual image, it must be erect. Next we will see about the real and inverted. As you see in real and inverted, this is a candle and here is a screen. So when we see the image of the candle on the screen, we notice that head of the candle now becomes the tail of the image and the tail of the object becomes the head of the image. So they are reversed here. Head becomes tail and tail becomes head. So up becomes down and down becomes up. So this is an example of inverted. And real image is always inverted. Virtual always erect, real always inverted. Now we will study about the characteristics of plane mirror. So first characteristic of the plane mirror is plane mirror always forms virtual and erect image. This I just explained you. Second, the size of image is equal to the size of object. If the object is 5 centimeter height, so image will also be the 5 centimeter height. And third characteristic is the distance of the object from the image is equal to the distance of image from the plane mirror. So here u is the distance of the object from the plane mirror and v is the distance of the image from the plane mirror. So for plane mirror, u will be equal to v. And this is the height of object and here is the height of image. So height of object is equal to the height of image. And you see that head is matching with the head and tail matches with the tail. So all the three characteristics of the plane mirror is explained in this figure. Next characteristics is plane mirror shows lateral inversion. Lateral inversion is a phenomenon in which the right side of the object appear left side of the image and vice versa. It means that if we have a plane mirror and here is a person, if the person raises our left hand, so in the image it shows right hand. You can also notice that when you are standing near the plane mirror and raise your left hand, for mirror it will be reverse. As you see in this figure, boy is lifting the left hand, but here on the mirror it shows right. So this is a concept of lateral inversion. We can take one more example for better understanding. I am taking a practical example. On ambulance, you see that on the front, it's not written ambulance properly. It's written in the reverse order. If we are riding a car, so we have a rear view mirror. So here this is our rear view mirror, which we consider as a plane mirror. So when we see the ambulance in this plane mirror, A is present on the left side, so it will come on the right side. After that, M will come, then B. This is the B, but in the mirror, it will be reverse. Next is U. U will be written as it is. Then L. L will be again reverse, so it is written as L. A. A is symmetrical, so no need to change as it is A is written. N is written like this way, then C and E. So you see in the ambulance, exactly same way. But when it comes on the mirror, so it will show complete ambulance. So easily they can read that ambulance is passing. We completed plane mirror. Now we'll start our next topic, a spherical mirror. A spherical mirror are those mirrors whose reflecting surface is curved. Plane mirror was completely plane. If we make little bit curved like this, so it becomes a spherical mirror. So there are two types of spherical mirror. First is convex mirror, second is concave mirror. So we will understand both the mirrors one by one. Here we took a spherical glass, and suppose if we cut this glass like this. So in the first glass we are taking a outer surface as a reflecting surface, and in the second one inner surface as a reflecting surface. So based on that, we have two types of a spherical mirror. One is a convex mirror, second is a concave mirror. When we are taking the outer one as a reflecting surface, it is a concave mirror, and inner one when we are taking as a reflecting surface, it is a concave mirror. So you see that convex mirror is bulging out, means it's going outward direction, and concave mirror is bulging in, it's moving inward direction. So based on that, we can differentiate concave and convex mirror. In concave mirror, as you see, this is a diagram here. In this diagram, when we are taking a concave mirror, it's bulging in. And if we take the incident ray, which is parallel to each other, so after that, based on law of reflection, these are normal. So all the incident ray will get reflected. And after reflecting, you see they meet at a point. So here, incident ray were parallel to each other. After that, reflected ray started converging. Converging means if incident ray has to pass straight, but because of the plane mirror, it changes its direction, inward direction. So it is converging in nature. So concave mirror is converging in nature. This we have to remember. Reflecting surface is curved inward, so concave mirror is converging in nature. Next is convex mirror. So convex mirror is bulging out. This is a convex mirror. So here is the incident ray which is parallel to each other. When it touches the surface, it gets diverged. So convex mirror is curved outward and it is diverging in nature. Now I will explain you how this converging or diverging nature is formed in a concave mirror and a convex mirror. First point, we have to always know that law of reflection is a universal law. It means that if we are using any mirror, whether it is a plane or a spherical, always law of reflection is followed. So here is a convex mirror and this is a concave mirror. So when the incident ray touches the surface, this is the normal. And we know that angle I is equal to angle R. And also we know that angle I is the angle between incident ray and the normal. This is normal, this is incident ray, this is angle I. Same way, this is reflected ray, this is angle of reflection. So you notice that the reflected ray is going outward direction. So it is diverging in nature. Similarly, if we take for a concave mirror, this is the incident ray, here is the normal. So we know that this is angle of incidence, this is angle of reflection. So here is the reflected ray. So reflected ray is moving inward direction. So that's why it is converging in nature. I hope this part is completely clear. Now we will study about the common terms used in the spherical mirror. So in common terms used in the spherical mirror, first we will see about the pole. It is the center of a spherical mirror. If you have any spherical mirror, like this is a concave mirror, so the center of this mirror is called as pole. Similar way, for a convex mirror, the center of it is called as pole. Next is center of curvature. Center of curvature is defined as the center of a hollow glass sphere of which the mirror was a part. Suppose we are considering a concave mirror. This is a concave mirror. So we assume that concave mirror we are taking out from a spherical hollow glass. So this is the spherical hollow glass. So this is the spherical hollow glass. And the center of this spherical hollow glass is considered as a center of curvature. Same way, if we take a convex mirror like this and we assume that it is taken out from a hollow spherical glass, so its sphere is this, and the center of this sphere is called as center of curvature. Next is radius of curvature. So as we know that center of curvature is the center of the hollow spherical glass, so radius of curvature is the distance between the pole and the center of curvature. So if this is the center of curvature and here is the pole, so the distance between the pole and center of curvature is considered as radius of curvature. It is represented as capital R. So this is example for concave mirror. Similarly, for the convex mirror, this is the center of curvature and this is the pole and this distance is capital R, radius of curvature. One point you have to note it down. Center of curvature in concave mirror is always on the reflecting surface. But for a convex mirror, center of curvature is in the non-reflecting surface. It means that center of curvature here is virtual. We can't see the center of curvature in term of convex mirror. Next is principal axis. Principal axis, the line joining the pole and the center of curvature. It is imaginary line. So here you see this is our center of curvature, here is the pole. If we join center of curvature and a pole through the imaginary line, it is called as principal axis. Same thing for a convex mirror. This is the principal axis. It is passing through C and P. Next is principal focus. Principal focus is important term. We will use this everywhere in the light chapter. So principal focus is the point on the principal axis where all the parallel ray is actually meet or appear to meet after reflection. I have two diagrams, one with respect to concave mirror and other with respect to convex mirror. So our incident ray must be parallel to the principal axis. This is our principal axis and here is the incident ray. Both principal axis and the incident ray must parallel to each other. So after reflection, this is the reflected ray and here is another incident ray. This is the reflected ray. Both the reflected ray will pass through the principal axis and meet at a point. This point is considered as a principal focus. Same concept we will understand with the convex mirror. Here is the incident ray, this is the normal, this is the reflected ray. Same thing, here is the incident ray and this is reflected ray. So in this case, reflected ray will form a virtual image. Reflected ray will pass through the non-reflecting surface and meet at a point on the principal axis. This point is called as principal focus. As I told you previously, for a concave mirror, center of curvature is real, but for a convex mirror, it is virtual. Similarly, principal focus is real for a concave mirror, but it is virtual for a convex mirror. These are the small points you always has to keep in your mind. Sometimes MCQ question comes based on these concepts. Next is focal length. Focal length is the distance between the pole and the principal focus. It is represented as a small f. This is example for a convex mirror. So here is the principal focus, this is the pole, and the distance between principal focus and the pole is considered as focal length. Similarly, for a convex mirror, pole and principal focus distance is focal length. So focal length in the convex mirror is on the right side and for the concave mirror it is on the left side. Next is aperture. Aperture is defined as the effective diameter of a spherical mirror. Suppose if you have any spherical mirror and the diameter of the spherical mirror is considered as the aperture. Suppose if you take a concave mirror and if we measure its diameter, then it is defined as a aperture. For your better understanding, I took an example. This is a spherical mirror and it's a convex mirror. And if we measure its diameter, this is the aperture. Now we will study about the relation between radius of curvature and the focal length. Focal length is represented as a small f and radius of curvature is represented as capital R. So here in a concave mirror, you see this is the principal focus, this is the center of curvature and here is the pole. So principal focus always lies between the center of curvature and the pole. So principal focus is the midpoint of the C and P. So if the distance between P and C is represented as capital R and the distance between P and F is represented as a small f, which is focal length, and focus is the midpoint of the C and P, it means that radius of curvature is 2 times of the focal length. So R is equal to 2F. So F is equal to R by 2. Sometimes in numericals we will use this relation. Now we will study about the rules of image formation in the spherical mirror. There are few rules of image formation. It will help us to understand the image formation in the spherical mirror. So first rule says that when the incident ray is parallel to the principal axis, after reflection, reflected ray must pass through the principal focus. If this is a concave mirror here and here is the incident ray, so when the incident ray is parallel to the principal axis, after reflection, this is the reflected ray, it must passes through the focus. Similarly, in the convex mirror, this is the incident ray and it is parallel to the principal axis. So after reflection, this is the reflected ray. So reflected ray must passes through the focus. But in the convex mirror, focus is present on the right side, which is the virtual side. So reflected ray can't go inside the mirror, so it will represent it as a dotted line. Second rule is, in this rule, when the incident ray passes through the principal focus after reflection, its reflected ray is parallel to the principal axis. You can say that it is a reverse or the converse of the previous rule. Here we will take the incident ray passing through the focus. This is the incident ray and it passes through the focus. After reflection, reflected ray is parallel to the principal axis. So this is example for concave mirror. Similarly, if we see for the convex mirror, this is the incident ray and this incident ray is in the direction of the principal focus. So after reflection, it will reflect and it will be parallel to the principal axis. Next rule is, in this rule, when the incident ray passes through the center of curvature, after reflection, it bounces back in the same path. So here you see this is the incident ray and this incident ray passes through the center of curvature. So when it is passing through the center of curvature, it touches the surface and its reflected ray is bouncing back in the same direction. So here I and R both are on the same path but in opposite direction. So this is for concave mirror. For convex mirror, center of curvature is behind the mirror. So when we take the incident ray, which is almost passing through the center of curvature, so its reflected ray will bounce back in the same path. So how this happen, I will explain you. We know that if we have a plane mirror and when the incident ray is perpendicular to the plane mirror or incident ray is coinciding with the normal, reflected ray will follow the same path in opposite direction. Why? Because angle I is equal to angle R and both are equal to 0 degree. So same concept if we apply for the mirror. If we have a concave mirror, this is pole, focus, center of curvature. When the incident ray passes through the center of curvature, so here normal and the incident ray both coincide with each other. That's why when the incident ray touches the surface, the reflected ray bounces back in the same path. Next rule is, when the incident ray touches the pole, it gets reflected and principal axis behave as a normal. So here this is the incident ray, here is the pole. When the incident ray touches the pole and gets reflected, principal axis behave as a normal. So this is for concave mirror and here is a convex mirror. This is incident ray, this is reflected ray and here is the normal. Now we will use all these four rules in image formation of the spherical mirror. So in image formation of a spherical mirror, first we will see the image formation in a concave mirror. When we are using a concave mirror, there are total 6 positions of the object: at infinity, beyond center of curvature, at center of curvature, between center of curvature and principal focus, at principal focus, between principal focus and the pole. Means object can be at infinity, beyond center of curvature, at center of curvature, between center of curvature and the principal focus, at principal focus and between principal focus and the pole. So these are the 6 position of the object. So first we will start with the object position at infinity. When the object is at infinity, incident ray is parallel to the principal axis. So if we have two incident ray, 1 and 2, this is our concave mirror. So both are parallel to principal axis. So based on rule number 1, when the incident ray is parallel to the principal axis, it must passes through the focus. So as you see, both the reflected ray passes through the focus and at focus image is formed. So based on the diagram, the nature of image is highly diminished because you see it's forming a dot here. So it's very small. It's real and inverted. How we will identify it's real or inverted? When the object and the image lies on the same side, then it is real and inverted. Object is on the left side and the image is also on the left side of the concave mirror. So it is real and inverted. Image is formed at focus. So here image is formed at focus. Now we'll see that when the object is beyond center of curvature. So in ray diagram of beyond center of curvature, object is present beyond the center of curvature. Here this is the object and this is the height of object. So always we will consider two rays. First we will take parallel ray. So when the ray is parallel to the principal axis, it must passes through the focus. And second, we can take the when the incident ray is passing through the focus, it will become parallel to the principal axis. So after drawing these two rays, you will notice that both the reflected ray meeting at this point. So here this is the image. So the nature is diminished. Diminished means height of object and height of image if we compare. So height of object is greater than height of image. So it is considered as diminished. And it is real and inverted because it is on the same side as the object. Image is formed between center of curvature and the focus. You see that here is the image and it is present between C and F. Next is at center of curvature. So here ray diagram we will see when the object is at center of curvature. This is the height of object and again two rays we will take. One is parallel, so it must passes through focus, and another is passing through the focus, so it must parallel to the principal axis. So both the reflected ray meeting at this point. So this is the height of image and this image is formed at center of curvature. So in this case height of object is equal to height of image. It is real and inverted, same size as the object. Image is formed at C. Next is between C and F. In this ray diagram, you notice object is present between C and F. Two rays we will consider. One is parallel ray, so it will always passes through the focus. And second, here we can consider with the pole. So both the reflected ray is meeting at a point, and this point is beyond center of curvature. And height of object is less than the height of image. So here in this case image is magnified. So the nature of image is it is magnified, real and inverted, and image is formed beyond center of curvature. You see the image is beyond center of curvature. Next is when the object is at focus. So here is the ray diagram of object at focus. So when we take the object at focus, two rays we will follow. One is parallel, which is passing through the focus, and another is passes through the pole. So both the reflected ray is parallel to each other. And when two rays are parallel to each other, we assume that it will meet at infinity. When the object is meeting at infinity, it means that the height of the image is very big. It is highly magnified. So the nature of image is highly magnified, real and inverted. Image is formed at infinity. So you see all the image is real and inverted. But the next ray diagram, when the object is present between F and P, it is a case of virtual and erect. So here this is the diagram. If we place the object between F and P and we take two rays, one is parallel, so it must passes through focus, and another through the pole we can consider. So here the rays are diverging. So when the ray is diverging, it means that it must have some starting point. If I have a two rays like this, so if I extend it, definitely there is a point from there these two rays are expanding. So if we make a dotted line, So we will notice that both the reflected ray is meeting on the right side of the concave mirror or the non-reflecting surface side. So here this is the height of image and here is the height of object. So height of image is more than the height of object, so it is magnified, virtual and indirect, because object and image both are in the opposite side. Image is formed behind the mirror. I summarize ray diagram and image formation in a concave mirror so it will be easier for you to remember. So O represents object and I represents image. So in the ray diagram, we notice that when the object is at infinity, image is at focus and the size of image is highly diminished. If I change this, means object is now at focus, so image is formed at infinity and it is highly magnified. So basically it's a reverse. Initially when the object was at infinity, image was at focus, but when the object is at focus, image is at infinity. Second, you will notice that initially it was highly diminished, now it is highly magnified. Similarly, when the object is beyond C, image is between C and F and it is diminished. When the object is between C and F, image is beyond C and it is magnified. This is also reverse. When the object is at C, image is at C, same size. And this is the spatial ray diagram where object is between F and P, image is formed behind the mirror and it is magnified. By this method, you can easily remember the nature of image in a concave mirror. Now we'll study about the convex mirror image formation. So this is a convex mirror and here is the right side which is a non-reflecting surface and left side is the reflecting surface. Focus is on the right side and center of curvature is on the right side. So in convex mirror, object can be placed at infinity or between infinity and pole. So you can note it down, position of object at infinity and between infinity and pole. First we will see that when the object is at infinity. When the object is at infinity, this is the ray diagram of a convex mirror. This is a convex mirror. We know that when the object is at infinity, incident ray is parallel to the principal axis. So this is our two incident ray. Both are parallel to the principal axis. So convex mirror is a diverging mirror. So you see these two rays, reflected ray, are diverging in nature. And if any ray are diverging, there must be a meeting point. So if we make a dotted line and join it, so we notice that reflected ray is meeting at focus. Here focus is virtual, but it will meet at focus. So the nature of image is highly diminished because at focus is a small dot. Virtual and erect because image and object both are in the opposite side. Image is formed at focus. Now we'll see when the object is present between infinity and pole. This is the ray diagram. Between infinity and pole, object can be placed anywhere. So if the object is placed here, two rays we will consider. One is parallel. So after reflection, parallel incident ray will pass through the focus. Second, we can take through the pole. Its reflected ray is moving like this way. Both the reflected ray is meeting at this point and this lies between P and F and it is diminished. So the nature of image is diminished, virtual and erect, image formed between pole and focus. So convex mirror always forms virtual and erect image and it is always diminished. These 2 points we can remember. Here I also summarized. In plane mirror, always virtual image is formed, but the size of image is same as size of object. In concave mirror, virtual image is only formed between P and F, and its nature is magnified. In a convex mirror, always virtual image is formed, but it is diminished. So generally, based on this concept, 1 mark question comes in board exam. Now we'll study about the uses of a spherical mirror. So first we will see about the concave mirror. So concave mirror is used in torch vehicle headlight. You see here in this figure, this is a concave mirror and this is the focus. Focus you can consider as a bulb. So when we glow the bulb in the torch, incident ray will be formed. And this incident ray, it is coming out from the focus. So after reflection, its reflected rays parallel to each other. So we can see the far object easily. Concave mirror used by dentists to see large image. Concave mirror is also used in the saving mirror and it is also used in the solar furnace. Now we will study about the usage of convex mirror. First use of a convex mirror is rear view mirror. Rear view mirror is used in a car to see back from the seat. So here is a question, why we use convex mirror as a rear view mirror? So the answer is plane mirror always form same size as object and its viewing angle is less. But in a convex mirror, it will form the diminished image. So its viewing angle is more. You can understand by a figure here. This is a plane mirror. When we see any object which is back side, we have a range of this. Means only in this range we can see the object. If any object is present here, we can't see that. But if the same thing we are doing with a convex mirror, because of its bulging out nature, we can see a wider angle. This is a wider angle. So that's why we are using a convex mirror in rear view mirror. Next use is, it is used as a parking mirror. This is a parking mirror. So if we have to see which car is coming, we can easily see through this. And here viewing angle is more, so we can easily cover the complete road. Second, it is also used as a security mirror. So these are the uses of a spherical mirror. Now we will study about the linear magnification. So from here, our main focus is numerical. In linear magnification, linear means one dimensional, means any one axis, x-axis, y-axis, z-axis. Magnification means how much image is enlarged or magnified. So the definition of linear magnification is the ratio of height of image to the height of object. It is represented as a small m. Hi we represent for height of image, Ho we represent for height of object. So the formula of linear magnification is height of image by the height of object. M is equal to Hi by Ho. And always remember, in these formulas, we always use the sign convention. I will explain you shortly. Linear magnification formula can also be written as linear magnification is equal to negative of distance of image to the distance of object. Distance of image is represented as V and distance of object is represented as U. So M is equal to minus V by U. So if we combine both the formulas, M is equal to Hi by Ho, it is equal to minus V by U. So this formula we will use to solve the numerical problems. In this module, we will study about the sign convention of a spherical mirror. First, we will study the sign convention of concave mirror. So this is a concave mirror, focus, pole, center of curvature. This is the focal length. Here is the radius of curvature. So in sign convention, we follow a specific rule. This side is our right side. Right side is non-reflecting surface for concave mirror. And the left side is the reflecting surface for a concave mirror. So left side is considered as negative and right side is considered as positive with respect to the pole. If we go towards the right, it is positive, left is negative. Similarly, with respect to the principal axis, upward direction is considered as positive and downward direction is considered as negative. So based on this, we will write down the sign convention for concave mirror when the object is forming a real image. We know that concave mirror can form a real image as well as virtual image. First, we will see the sign convention of a concave mirror in terms of real image. So here I took a ray diagram of an object which is present between C and F. So we have studied earlier that the image between C and F is real and inverted. It is magnified and the image is beyond center of curvature. So AB is the height of object. AB is the height of object. A dash B dash is the height of image. AP is the distance of object from the pole, which is represented as U, and A dash P is represented as V, which is the distance from image and the pole. FP is the focal length, small f, and CP is the radius of curvature. So if we use the rule of sign convention, you see that U is present on the left side. So it must be negative. So that's why here U is negative. V is present on the left side. So it is negative. It's negative. Focal length is present on the left side. Again it is negative. Height of object. It is upward direction. So it must be positive. So positive and negative for the height of image and object we will not consider with right or left side. It is only up and down. So here AB is upward direction, so it is positive. A dash B dash is downward direction, so it is negative. And R is the radius of curvature, so it is also the negative direction. So these are the sign convention of concave mirror in term of real image. Now we'll see in term of virtual image. Now we took a concave mirror in term of virtual image. So we know that in concave mirror, virtual image is only formed when the object is between F and P. So here is the object and this is the image. So U, which is the distance of AP, is present on the left side. So U is negative. V is A dash P. So it is on the right side. So it is positive. Focal length. Focal length for a concave mirror is always on the left side. So whether it is real or virtual, in both the cases, it is negative. Height of object is positive because it is upward direction. And height of image is also positive because it is upward direction. So in the virtual case, height of image sign convention changing. Previously it was negative, now it become positive. And the sign convention of U is also changing. Previously it was negative for the real, for virtual it is positive. R remains the same because R and F, it doesn't depend upon the position of object, it depends upon the type of mirror. So here it is a concave mirror, so it is negative. Now we will see the sign convention in term of convex mirror. Convex mirror always forms virtual image. If I take a ray diagram where the object is present between P and infinity, so we already know that image is formed between P and F, it is diminished and it's virtual and erect. So here is the U, AP is the U. U is present on the left side, so it is negative. V is present on the right side, so it is positive. F is always on the right side, so here focal length for the convex mirror is always positive, so that's why here it is positive. Height of object is positive because it is upward direction, and the height of object is also positive because it is upward direction. Our radius of curvature is on the right side, so it is positive. So convex mirror has only one sign convention. So you must have to remember sign convention when you solve any problem. Without sign convention, you will never get a correct answer. Now we will see sign convention in term of linear magnification. So in linear magnification sign convention, for concave mirror, if we consider the real image, then M is negative. So when linear magnification is negative, it means it is real and inverted. Similarly, for a convex or concave mirror in term of virtual image, if we get it as positive, so it must be the virtual and erect. I hope this part is completely clear for you. So let's try one problem based on linear magnification sign convention concept. Here in this question, when in the A part m is equal to plus 1, B part m is equal to plus 2 and C m is equal to plus 1 by 2, which mirror is used? Let's understand this question. We know that when m is equal to positive, it will always forms virtual and erect. And when m is negative, it is real and inverted. So in the first case, m is equal to plus 1. So plus represents virtual and erect. So what is the meaning of 1? 1 means we know that m is equal to hi by ho, and in this case m is equal to 1. So height of image is equal to height of object. So which mirror forms virtual and erect image as well as height of image is equal to the height of object? It is only the plane mirror. So for the first part, plane mirror is the correct answer. In the second part, m is equal to plus 2. So we know that plus means virtual. And what is the meaning of 2? So m is equal to height of image by height of object. M is 2. So it means that height of image is 2 times of height of object. So it is a case of magnified. So concave mirror in case of virtual image can form the magnified image. So in the second one, it is a concave mirror. Next is when m is equal to plus 1 by 2. Plus same thing as before, it is virtual and erect. And m is here 1 by 2, which is height of image by height of object. So height of image is half of height of object. So it is a case of diminished. So convex mirror can form the diminished image. So this is the answer. Now we will study about the mirror formula. Mirror formula is a relation between u, v and f. U is the distance between object and pole, v is the distance between image and pole, and f is the distance between principal focus and the pole. So the mirror formula is 1 by f is equal to 1 by u plus 1 by v. And always remember, when we solve this problem, we must have to use the sign convention. I will explain you few problems so you will know how to use these formulas to solve the problem. In this question, a convex mirror used for rear view on an automobile has a radius of curvature 3 meter. If the bus is located at 5 meter from the mirror, find the position, nature and the size of image. So first we always draw the ray diagram based on the question. So here this is a convex mirror and we have focus, center of curvature, and it is present on the non-reflecting surface. So according to the question, R is given as 3 meter. So it is plus 3 meter and object is present 5 meter from the mirror. So U is minus 5 meter. So we will first write the given values. U is equal to minus 5, R is equal to plus 3. And we have to find the value of V, means where the object is present. This value we have to find and its magnification, M. Because in the question we have to find the nature and the size of the image. So first we will find the position of image, which is V. We know that radius of curvature is equal to 2 times of the focal length. So F is equal to R by 2. And according to the question, R is plus 3. So 3 by 2 is 1.5 meter. Why we are finding F here? Because we have mirror formula. In the mirror formula, U is known. We have to find V, but F is not given. So our first work is to find the F. And after finding the f, we can use the mirror formula to find the v. So 1 by f is equal to 1 by v plus 1 by u. So if you substitute the value, f is 1.5, we just got it. And we know that u is equal to minus 5. So 1 by v is equal to 1 by 1.5 plus 1 by 5. After taking LCM, 1 by v is equal to 10 plus 3 by 15. So v is equal to 15 by 3. It's equal to 1.15 meter. So this is the position of image. Means image is present at a distance of 1.15 meter. So here in this diagram, somewhere it is present 1.15 meter. Now second thing, we have to find the linear magnification. For finding m, we will use linear magnification formula. M is equal to minus v by u. So v value, we will take the fractional value, which is minus 15 by 13 divided by minus 5. So if we solve it, m is equal to 3 by 13. It's equal to plus 0.23. Linear magnification is dimensionless. So here m is positive and it is less than 1. So it is virtual and erect and it is diminished. So this is the nature of image. Let's try next question. In this question, an object 4 centimeter in size is placed at 25 centimeter in front of a concave mirror of focal length 15 centimeter. At what distance from the mirror should a screen be placed in order to obtain a sharp image? Find the nature and the size of image. So here in the question, 4 centimeter in size, it represents height of object. 25 centimeter object is placed, it represents u, and focal length is 15 centimeter. We have to find the distance of the image from the mirror. So as you see in this figure, this is a ray diagram of this question. Here this is the object and the height of object is 4 centimeter. The distance of the object from the pole is minus 25 centimeter and f is minus 15 centimeter. U and f is negative based on the sign convention of a concave mirror. So here given u is minus 25, f is minus 15 and height of object is plus 4. And we have to find the value of v, magnification m and the height of object. So if we have to find the v, we will use the mirror formula. By mirror formula, 1 by f is equal to 1 by v plus 1 by u. F is equal to minus 15, u is equal to minus 25. So if we write it as 1 by v is equal to minus 1 by 15 plus 1 by 25 after taking LCM, 1 by v is equal to minus 2 by 75. If we reciprocate, v is equal to minus 75 by 2, minus 37.5 centimeter. So this is the value of v. Now we have to find the magnification. So for finding the magnification, we will use the linear magnification formula. So we know that m is equal to minus v by u. So v value is equal to minus 75 by 2. We got this value previously and u is minus 25. So if we solve it, we will get it as m is equal to minus 75 by 2 into 1 by 25. So m is equal to minus 3 by 2 and it is equal to minus 1.5. So previously I told you when it is negative, it means it is real and inverted. And it is 1.5. So it is more than 1. So it means that it is also magnified. So we got the magnification value. Now we will find the height of image. So m is equal to hi by ho. So if we write hi is equal to m into ho and m is minus 1.5, height of object is 4 centimeter. So height of image is equal to minus 6 centimeter. So what is the nature of image? Nature of image is real, inverted and magnified. This is the answer of this question. Here I share few questions for your practice. This is the end of part 1. In next video, we will study about the refraction of light. If you like this video, please subscribe it, share it, and if you face any problem, you can also comment me in the comment box. Thank you.